continue.
Okay. Very good day to Encik Nurul Halim bin Hasim. We are from 4BET, session 11, are going to present our lab 5, path loss model analysis. I am Archana Sri and these are my lab partners, Ranjita and Najiha.
Wait, Tachina, did you turn on your camera?
Yes.
Okay.
Okay, we did this lab by using MATLAB software. We copy the program given and run the program to record the output. We follow the data in the table 4.2 with the frequency given, frequency, distance, transmitting antenna gain, receiving antenna gain, PT, and we find the path loss in dB, receiving power in dB, and receiving power in watts. And these are the results we got from the MATLAB software. Okay.
Number 4.
For number 4, we use the MEASAT satellite information to find the path loss and the output power. The frequency is 14500 and the distance is 421,064 kilometers.
42,000.
42,000.
Oh, sorry, 42,164 kilometer. Transmitting antenna gain is 57.8 dB. Receiving antenna gain is 70 dB and transmitted power is 60 dB. And we got the path loss, receive power and receive power in watts.
Okay, I will proceed with the question part. So the first one is we have to do comparison. So question A is comparison between step 1 and step 2 to see what is the output when we modify the frequency value. So when the frequency value is increased to 2000 MHz from 1000 MHz, the path loss has increased, and as the loss increases, the received power has decreased. By comparing step 3 and 4, we have...
Ranjita.
Yes.
Archana, can you see Ranjita face?
Yes, can.
Okay.
Okay, so what happens to the output when you modify the distance? When the distance is increased from 200 km from 100 km, the path loss has increased. As loss increases, the received power becomes lesser. And for step 5 and 6, what happens to the output when we modify the power transmitter value? When the transmitted power is increased to 20 dB from 10 dB, the received power has increased while path loss remains constant.
Okay, next is for question number 2. We need to show the calculation theory to compare the result from MATLAB software. As you can see, there's the calculation for free space path loss in dB. The equation is 20 log 10, d is distance, plus 20 log 10, f for the frequency, plus 32.44. And then for the answer is 132.44 dB, same as the result that we got. Then for the power received in dB, the equation is power transmitter plus gain transmitter plus receive gain minus free space path loss. Then the answer we got is negative 110.44 dB. And then for the watt, in watt, the answer is 9.04 to the power of negative 12 watt. For the all calculation that we do, we got the same result as the MATLAB software. The same goes with the other frequency. Next, we proceed to the discussion. We're using the MATLAB software to calculate the path loss analysis. Path loss is important in designing the link budget in a telecommunication system. Path loss decrease in influence thickness, which is weakening of an electromagnetic wave as it's spread. Najita, can you scroll up?
Yeah.
Okay. I repeat that. Path loss is decrease in influence thickness of an electromagnetic wave as it spread through space. This term is usually utilized in remote correspondence and sign engineering. Path loss might be because of a numerous impacted, for example, free space loss, refraction, diffraction, reflection, aperture medium coupling loss, and absorption. Path loss also impacted by landscape shapes, climate, metropolitan or rustic, vegetation, and foliage. Engineering medium or dry or wet air. The distance between the transmitter and the collector and the height and location of antenna.
Okay, so I will close the discussion with a conclusion. So as a conclusion, we have learned about free space path loss and able to write MATLAB coding for the path loss analysis. So free space path loss is the loss in signal strength that occurs when an electromagnetic wave travels over a line of sight path in free space. We understood the calculations to obtain free space path loss, and we have done manual calculation to compare the results that we obtain in the MATLAB software. And lastly, we have done analysis to see the effect on path loss and received power by changing the frequency, distance, and transmitted power. That's all from us.
Thank you.
Thank you.
Thank you.